Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders, and my dear students. Hearty welcome to Department of Mathematics. Today, once again, we are going to discuss about paper 2, that is three-dimensional analytical solid geometry, unit 5, cones. In this particular topic, we are going to learn about notations and finding the vertex of the cone. The presenter is Ms. Y. Padmaja, lecturer in charge, the Department of Mathematics. So let us start the program. Now we use the following notations. S is represented by ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d. And capital E is not denoted by E of xyz, which is a homogeneous polynomial in xyz, namely ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy. And capital U is given by, it is a linear polynomial in xyz defined as ax plus hy plus gz plus u, and capital V is denoted by hx plus by plus fz plus v, and capital W is given by gx plus fy plus cz plus w, and capital D is denoted by ux plus vy plus wz plus d. Further, u1 is nothing but replacing xyz in capital U by x1 by y1 z1. That is, u1 equal to ax1 plus hy1 plus gz1 plus u, and v1 is denoted by hx1 plus by1 plus fz1 plus v, and w1 is given by gx1 plus fy1 plus cz1 plus w, and capital D1 is denoted by ux1 plus by1 plus wz1 plus d. Now capital S1 is denoted by AXX1 plus BYY1 plus CZZ1 plus F times YZ1 plus Y1Z plus G times ZX1 plus Z1X, H times XY1 plus X1Y, and U times X plus X1, V times Y plus Y1 plus W times Z plus Z1 plus D. Now rearranging the terms by taking the coefficients of x, y, z and separately the constant terms, we see that ax1 plus hy1 plus gz1 plus u times x, hx1 plus by1 plus fz1 plus v times y, gx1 plus fy1 plus cz1 plus w times z, ux1 plus vy1 plus wz1 plus d. That is nothing but u1x plus v1y plus w1z plus d1. And further, we can rearrange and write this as S11 equal to U1 X1, V1 Y1, W1 Z1 plus D1. Now we are going to learn about a simple theorem. If X1, Y1, Z1 is the vertex of the cone S is equal to 0, then U1, V1, W1 and D1 becomes equal to 0. Now the proof. Let the equation of the cone be ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d equal to 0. Now, given that, let us say that the vertex of the cone B, capital P equal to x1, y1, z1. Now, shifting the origin to the point P, the new equation of the cone referred to the vertex P becomes the origin, new origin. So this equation now will be transformed into a times x plus x1 whole square plus b times y plus y1 whole square plus c times z plus z1 whole square plus 2f times y plus y1 into z plus z1 plus 2g times x plus x1 into z plus z1 plus 2h times x plus x1 into y plus y1 plus 2u times x plus x1 plus 2v times y plus y1 plus 2w times z plus z1 plus d equal to 0. Now, rearranging these terms, we see that ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2x times ax1 plus hy1 plus gz1 plus u, 2y times hx1 plus by1 plus fz1 plus v, 2z times gx1 plus fy1 plus cz1 plus w, plus ax1 square plus by1 square plus cz1 square plus 2fy1z1 2gz1x1 plus 2hx1 by1 plus 2ux1 2by1 plus 2wz1 plus d equal to 0. Now, this is nothing but E of xyz plus 2u1x plus 2v1y plus 2w1z plus s11 equal to 0. This must be a homogeneous equation. So what is the condition? u1 must be equal to 0, v1 must be equal to 0, w1 must be equal to 0, and further d1 must be equal to, that is s11, the constant term also should be equal to 0. So when the constant term S11 0, what is S11? U1 x1 plus V1 y1 plus W1 z1 plus D1 equal to 0. But U1 is 0, V1 is 0, W1 is 0. Therefore, automatically D1 is 0. So finally, if x1, y1, z1 is a vertex, then what is the condition? U1 is 0, V1 is 0, W1 is 0, D1 is also equal to 0. That's all. Very, very good. Now, corollary one. If the equation S is equal to 0 represents the core, then what is the condition? The condition is nothing but the determinant. What is the determinant? A, H, G, U. H, B, F, V. G, F, C, W. U, V, W, D equal to 0. How to remember this? This is very, very simple. So in the diagonal, you just consider A, B, C, D, F, G, H. So in the diagonal, you write down A, B, C, D, and you can write F, G, H like this and F, G, H like this. And the vertical times U, V, W, D, automatically the last horizontal row with U, V, W. So A, B, C, F, G, H, F, G, H, U, V, W, U, V, W. That's all. That becomes equal to 0. Now we have seen that the condition for S is equal to 0 to have its vertex x1, y1, z1 is capital U1 is 0, capital V1 is 0, capital W1 is 0, capital D1 is equal to 0. From all these four equations, we are going to eliminate x1, y1, z1. So once again, let us repeat. What is the condition? In the diagonal, we are having A, B, C, D. And in the last column, UVW, here last row, UVW. So we are held up with the 3 rows below the diagram, 3 terms, 3 places, vacant places below the diagonal. Similarly, we have 3 places empty above the diagonal, that is FGH, FGH. So that becomes easily we can remember. Now corollary 2. The vertex x1, y1, z1 satisfies the equations, the following 4 equations. What are those 4 equations? Capital U equal to 0, capital B equal to 0, capital W equal to 0, capital D equal to 0. Now what is capital U? Ax plus hy plus bz plus u equal to 0. What is capital B? Hx plus by plus fz plus v equal to 0. Capital W, gx plus fy plus cz plus w equal to 0. And what is capital D? Ux plus Vy plus Wz plus D equal to 0. Thus, the vertex is obtained by solving any 3 of the above 4 equations. So, consider now how to prove this. Now, consider the homogeneous polynomial equation Sxyzt, because the vertex, we know that if the vertex is at origin, then it becomes a homogeneous equation. Similarly, now, in order to make it a homogeneous equation, we consider another parameter t. So, in the general equation of the code, we have seen it is represented by 10 terms: ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy. So, these 6 terms need not have any supporting system. But on the other hand, the next 3 terms, we are having only x, y, z. That means of power of degree 1 only. So in order to make it as homogeneous, multiply that with t. That becomes 2uxt, 2vyt, 2wzt. And the last term d is made homogeneous by multiplying that term with t square. Now consider the partial derivative of s with respect to x. That becomes 2 times of ax plus, and then we can easily see hy plus gz plus ut. And what is the partial derivative of s with respect to y? 2 times hx plus by plus fz plus vt. What is the partial derivative with respect to z? Dou s by dou z equal to 2 times gx plus fy plus cz plus wt. And what is dou s by dou t? That is nothing but 2 times of ux plus vy plus wz plus dt. Now equating the partial derivatives, this is dou s by dou x, dou s by dou y, dou s by dou z, and dou s by dou t, each to 0, and putting t equal to 1, we get capital U equal to capital V equal to capital W equal to capital D equal to 0. That's all. Very, very good. Okay, next. We consider the first example. If ax square plus by square plus cz square plus 2ux plus 2vy plus 2wz plus d equal to 0 represents a cone, then prove that u square by a plus v square by b plus c w square by c equal to d. Now what is given? A cone is given. And what is that we have to prove? We have to prove that if that equation is going to represent a cone, then the condition is going to be like this. So in order to, we do not know the vertex of the cone, let us assume that the vertex of the cone is x1, y1, z1. In order to have x1, y1, z1 as the vertex, what are the conditions? Capital U1 is 0, capital V1 is 0, capital W1 equal to 0, and capital D1 equal to 0. Now what is capital U1? That is the first row in the determinant. Ax plus hy plus gz plus u equal to 0. Here in the given equation, what is A? A is A only. What is H? No xy term. So H is 0, and G, that is ZX term. We don't have ZX term in the, so G is also 0. So we are landed up with only 2 terms, namely ax1 plus u equal to 0. That implies x1 equal to minus ua by minus u by a. Similarly, v1 equal to 0. We can see that the second row, that is v by 1 plus b becomes equal to 0. Therefore, y1 becomes minus v by b. And w1 is 0. That implies cz1 plus w equal to 0. Therefore, z1 is equal to minus w by c. And capital D1 equal to 0. What is capital D1? Ux1 plus Vy1 plus Wz1 plus D becomes 0. But what is U? We are going to substitute. What is x1? Minus U by A. So U into minus U by A plus V into minus V by B plus W into the minus W by C plus D equal to 0. So that implies U square by A plus V square by B plus W square by C equal to D. So that is the condition. Now consider the second example. Find the vertex of the cone 7x square plus 2y square plus 2z square minus 10zx plus 10xy plus 26x minus 2y plus 2z minus 17 equal to 0. Now consider the homogeneous equation. What is a homogeneous equation? S of x, y, z, t, that is equal to 7x square 2y square plus 2z square minus 10zx plus 10xy plus 26xt minus 2yt plus 2zt minus 17t square equal to 0. Now what is dou s by dou x? So 14x, next minus 10z plus 10y plus 26t. So that becomes 14x plus 10y minus 10z plus 26 when t is equal to 1. Similarly, consider the partial derivative of s with respect to y. That becomes 4y plus 10x minus 2t. That is nothing but 10x plus 4y minus 2. Now what is dou s by dou z? That is 4z minus 10x plus 2t. That is nothing but minus 10x plus 4z plus 2 when t equal to 1. Similarly, consider dou s by dou t. That is nothing but 26x minus 2y plus 2z minus 34t, that is equal to 26x minus 2y plus 2z minus 34. Now coordinates of vertexes satisfy these equations. That is 14x, 10y minus 10z plus 26. So we got these 4 equations. Now we have to solve these 3 equations, any 3 equations. And we can see that x becomes 1, y becomes minus 2, z becomes 2. Now substituting these values in 4, it gets satisfied. Hence, the vertex of the cone is nothing but 1, minus 2, 2. Now show that the equation 2y square minus 8yz minus 4zx minus 8xy plus 6x minus 4y minus 2z plus 5 equal to 0 represents a cone whose vertex is minus 7 by 6, 1 by 3, 5 by 6. Similar question. So we do the homogenization polynomial equation. So no need to y square for minus 8yz also. We don't have required anything. So minus 4zx minus 8xy plus 6xt minus 4yt minus 2zt plus yt square we consider that is equal to 0. Now dou s by dou x becomes simply minus 4z and then minus 8y plus 60. And dou s by dou y is given by 4y minus 8z and then minus 8x minus 4t. And dou s by dou z becomes minus 8y minus 4x and then minus 2t. And dou s by dou t is given by, that is 6x minus 4y minus 2z plus 10t. Now putting t equal to 1, the coordinates of the vertex of the equation satisfy the equations 4y 4y plus 2z minus 3 equal to 0. The second equation reduces to 2x minus y minus 2z plus 4 equal to 0. And the third equation becomes 2x plus 4y plus 1 equal to 0. And then further 3x minus 2y minus z plus 5 equal to 0. Now solving 1, 2, 3, we can easily see that x is equal to minus 7 by 6, y is equal to 1 by 3, z is equal to 5 by 6. Now substituting this value, okay, xyz in 4, we can see that it satisfies the equation. Hence, the vertex of the cone is minus 7 by 6, 1 by 3, and 5 by 6. Now, small theorem, a condition, and it is also an aesthetic question. The cone E of xyz is equal to 0 will have 3 mutually perpendicular generators implies unimplied by, that is a plus b plus c equal to 0. That is the quotient of x square plus quotient of y square plus quotient of z square becomes equal to 0. Now let us consider the homogeneous equation of xyz, that is represented by ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy equal to 0. Now let the generator of the cone be x by p equal to y by q equal to z by r. Therefore, what is now automatically the drs of the cone generator satisfy the equation of the cone. Therefore, we have E of P comma Q comma R equal to 0. That is AP square plus BQ square plus CR square plus 2FQR 2G RP 2H PR PQ equal to 0. The equation to the plane perpendicular to 1 and passing through the vertex is given by. So we have considered this line. And then now in this, what I'm going to do, that is, I'm going to consider a cone, and what I'm going to do, so actually I have to build up a cone containing 3 mutually perpendicular generators. So this is the generator. Okay. Now I'm consider the generator like this. Let us say this is the generator. So what is its equation? X by P, Y by Q, Z by R. So this is the code. Okay, that is the code generator. Now I'm going to construct a plane, I'm going to construct a plane perpendicular to this line. So this is the plane. Okay. Now this is the plane. Let us so I have considered the plane. How is this plane? The plane is perpendicular to this generator. Okay. Now automatically, what are the DRs of this particular DRs of this particular uh, plane? Sorry, generator. That is P. So this is P. Nothing but P, comma Q, comma. Okay, this is the generator. So this is given by this particular equation. And further, what is the equation of this particular plane? The plane is given by, this is the plane that is given by Px plus Qy plus Rz equal to 0. Okay, let this plane intersect the cone along two real generators. So let us say, so this plane is consisting of two generators. I'll consider this as one. Okay, I'll consider this as well. This is one generator. And I consider another one. I'm going to construct another one. So this is right, another one. So two generators. So because I do not know, I'm going to find out these two generators. In order to find these two generators, I'm going to consider now, that is, because I don't know the DRs of this particular, I'll consider this as L, M, N. So this is also passing through origin, no doubt about it. So where is this generator? This generator is on the cone, as well as this generator is on the plane. Okay. So this generator, so it should satisfy, that is we should get PL plus QM plus Rn equal to 0. Similarly, because this generator is on the cone, it should satisfy the equation of the cone, namely, that is AL square plus BM square plus CN square plus 2FMN plus 2GML plus 2HLM equal to 0. Therefore, we have PL plus QM plus Rn equal to 0. Now, eliminating n between 4 and 5, we get, that is nothing but L square times, that is we have to, okay, L square times, we get AR square plus CP square minus 2GRP, and 2LM times this becomes CPQ plus HR square minus GQR minus FRP plus M square times BR square plus CQ square minus 2FQR equal to 0. Now dividing that with M square, we get this particular condition. Now this is quadratic N. This is This is quadratic in L by M. So it will have definitely two roots, namely L1 by M1 and another one as L2 by M2. L1 by M1 and L2 by M2. Now, because it is having two roots, namely L1 by M1 and L2 by M2, we can easily see the product of roots is given by L1 by M1 into L2 by M2. That is nothing but the constant term by coefficient of square term. So what is the constant here? We can see that BR square plus CQ square minus 2FQR. And what is the square coefficient of square term? AR square plus CQ square minus 2G RP. So that becomes the L1 L2 by BR square plus CQ square minus 2FQR. That is equal to M1 M2 by AR square plus CP square minus 2G RP. Now by symmetry we can easily see that is equal to N1 N2 by, we can write after B we got A, after C we got after B we got the C. BR square is in cyclic order CP square. CQ square in cyclic order we got it as AR square. 2FG QR is represented by 2G after Q RP. Okay, so on cyclic order we can see that CP square is nothing but A Q square and AR square in cyclic order, that becomes B P square minus 2H into RP becomes, that is R becomes P becomes Q. So that is equal to K, let us say. But so we consider L1 L2 plus M1 M2 plus M1 M2 is nothing but K times we can write. That is, we can simplify and further modify, and we can see that it can be written as K times A plus B plus C into P square plus Q square plus R square. But how are these generators? They are perpendicular to each other. Therefore, L1 L2 plus M1 M2 plus M1 M2 equal to 0. That becomes A plus B plus C equal to 0. So since the plane 3 is perpendicular to generator 1, the two generators of intersection of the plane 3 with the cone are perpendicular to generator 1. Already we have seen one generator is perpendicular to the plane. The remaining two generators are in the plane. So totally all these three are perpendicular to each other. Therefore, the condition for a cone to possess three mutually perpendicular generators is nothing but A plus B plus C equal to 0. That is the finally we conclude. Now, so suppose the general equation AX square plus BY square plus CZ square plus 2FYZ plus 2GZX plus 2HXY plus 2UX plus 2VY plus 2WZ plus D is equal to 0 is equal. Then we are going to shifting the origin to the vertex of the transfer. Then the transferred equation becomes this equation. And the cone capital F of XYZ equal to 0 will have three mutually perpendicular generators. Implies and implied by E of XYZ is equal to 0 has three mutually perpendicular generators. That implies and implied by A plus B plus C equal to 0. That's all. Now show that the two lines intersection of the plane AX plus BY plus CZ equal to 0 with the cone YZ plus ZX plus XY equal to 0 will be perpendicular if 1 by A plus 1 by B plus 1 by C equal to 0. Given equation of the cone is YZ given cone YZ plus ZX plus XY equal to 0. Now here we see easily that the coefficient of x square plus coefficient of y square plus coefficient of z square is 0. Therefore, the cone contains sets of three mutually perpendicular generators. Now, given plane AX plus BY plus CZ equal to 0, what is it doing? It cuts the cone perpendicular in perpendicular generators. If its normal line through the vertex. So what is the equation of the normal to this particular equation? That is the drs of the normal to the plane are A, B, C. Therefore, the generator perpendicular to this is x by A equal to y by B equal to z by C is the generator of the cone. And so the DRs of the generator of the cone, namely A, B, C, they satisfy the equation of the cone yz plus zx plus xy equal to 0. Therefore, what is going to happen now? That is, instead of yz, we can write bc plus ca plus ab equal to 0. Dividing throughout the equation by abc, we have 1 by a plus 1 by b plus 1 by c equal to 0. So here also we can do the same thing. That is, we can see that we are having a plane, namely a plane is given, and further the plane is there, and so we have a line. So what is the equation of the plane? The equation of the plane is nothing but equation of the plane. What is the drs of the normal to the plane? A. Drs of the normal to the plane. Therefore, we have A, B, this they are having normal to this plane. Further, so what is the equation of the generator? X by A. So generator is given by x by A So this is the generator of the cone. X by A, y by B plus z by C. But where is this? The cone So we have to imagine a cone for three generators. So I will show you this one. All three are mutually propagating. Anyway, so this generator that we have taken x by a, y by b, z by c. Automatically, because this is on the cone, it should satisfy the DR cell generator should satisfy the equation of the cone. So we get that particular thing, that is yz plus zx plus xy equal to 0 will become EC plus CA plus AB equal to 0. Dividing that with the ABC, automatically we can see that that becomes the equation of the cone. Hope that is clear. Now next one, if the line x equal to 1 by 2 y equal to z represents one of the three mutually perpendicular generators of the cone, find the equation of the other two. So only one generator is given and cone equation is given. So we write down the cone equation and generator. So as usual, what we have to do? Again, we have to do the construction. How are we going to do the construction? That is, so how are we going to do the construction here also? As usual, here also we are going to consider, that is the line. Where is the line? Now x equal to 1 by 2. Previously we are having x by 1 equal to y by 2 equal to z by 1. So instead of ABC, what we are having is here, we don't have ABC, but we are having, what are they? They are nothing but now 1, 1, 1. Sorry, 1, 2, 1. So they are nothing but 1, 2, 1. So automatically, what is going to be the equation of the plane? That is 1 into x plus 2y plus z. So that is why we got the equation of the plane as x plus 2y plus z equal to 0. So we are having this from x plus 2y plus z equal to 0. That is the equation of the plane. Now, one of the generators we don't know. So we consider the generators, the DRs of that as L, M, N. Then automatically, where is this particular line element? It will be on the the generator x by L equal to y by M equal to z by N, that lies on the plane as well as that lies on the cone. Therefore, we get, therefore, 11 by z plus 6 zx minus 14xy equal to 0. And this is the cone equation, the plane equation. So it should satisfy these two conditions. What are they? 11 mn plus 6 nl. And further, we are having minus 4 lm. Okay. And further, we have L plus 2m plus n equal to 0. Now, from this, automatically, what is n? N equal to minus L minus 2m. Now, substituting this into, we are having 11m into minus L minus 2m plus 6 into n minus L minus 2m minus 4 lm equal to 0. Similarly, we are having, so on further simplification, we get like this 6L square plus 37Lm plus 22M square equal to 0. Now that can be written as the product of these two terms, 2L plus 11M into 3L plus 2M equal to 0. So we are having, that is 2L plus 11M equal to 0, one condition, and that one is 3L plus 2M equal to 0. Now solving, L plus 2M plus n equal to 0, 2L plus 11M by cross multiplication method, we get element values as minus 11, minus 2, and 7. Now solving L plus 2m plus n equal to 0, we get this. So in this way, we get the two perpendicular generators. This is a 10 marks question. So please pay attention on all this. Okay, I hope that is clear to one and all. Okay. Now we are having, that is, the next one is, show that if a right cyclic cone has sets of three mutually perpendicular generators, then its semi-vertical angle must be tan inverse root 2. So let element be the direction cosines of the axis of the cone and alpha be the semi-vertical angle. Then the equation of the right cyclic cone is given by Lx plus My plus Nz whole square equal to L square plus M square plus N square into X square plus Y square plus Z square into cos square alpha. Because the cone contains three mutually perpendicular generators, we have coefficient of X square plus coefficient of Y square plus coefficient of Z square equal to 0. Now what is coefficient of X square here? We get that is equal to L square minus of L square plus M square plus N square into cos square alpha. Coefficient of Y square is nothing but M square minus L square plus M square plus N square times cos square alpha. And coefficient of Z square is given by N square minus of L square plus M square plus N square times cos square alpha. Now adding the above three, we get L square plus M square plus N square equal to minus 3 times of L square plus M square plus N square times cos square alpha equal to 0. So on further simplification, 1 minus 3 cos square alpha equal to, so we get so 1 minus 3 cos square alpha equal to 0. That implies secant square alpha equal to 3. 3 cos square alpha equal to 1 or cos square alpha equal to 1 by 3. Therefore, secant square alpha equal to 3. But what is secant square alpha? 1 plus tan square alpha equal to 3. This implies tan square alpha equal to 2 or tan alpha equal to square root of 2 or alpha equal to tan inverse of root 2. That's all. What is the original equation? Okay. Now, show that the cone whose vertex is the origin and which passes through the curve of intersection of the surface 2x square minus y square plus 2z square equal to 3d square by any plane at a distance d from the origin has three mutually perpendicular generators. So equation of any plane at a distance d from the origin is given by Lx plus My plus Nz equal to d, where element are the drs of the normal to the plane. Now, what is the given equation of the surface? 2x square minus y square plus 2z square equal to 3d square. So we write that as we do the homogenizing this particular equation with one square. But what is one here? So one can be written as here. What do you have? We are having that is nothing but Lx plus My plus Nz, Lx plus My plus Nz plus Nz by d whole divided by d equal to 1. So we consider the homogenization of this equation. So this is simply 3d square into 1 square we can write. Now, if this is having three mutually perpendicular generators, then what is the condition? Coefficient of x square plus coefficient of y square plus coefficient of z square must become 0. So we check whether it is true or false. So now what is coefficient of x square? We are having 2 here, and here we are having minus 3l square. Similarly, a coefficient of y square, we are having minus 1, and then Here from this we get minus 3m square. Similarly from this we get 2z square minus 3n square. That becomes 2 plus 2, 4 minus 3, that is 3 minus 3 into, we can write that as m square plus m square plus n square. But L square plus m square plus n square are DCs of the normal to the plane, so that becomes equal to 1. So 3 minus 3 equal to 0. Hence, the plane 1 cuts the cone in 3 mutually perpendicular generators. Now, if the plane 2x minus y plus cz equal to 0 cuts the cone yz plus zx plus xy equal to 0 in perpendicular lines, then find C. Now, what is the condition as usual? Given plane, we have given cone yz plus zx plus xy equal to 0. So obviously it contains 3 mutually perpendicular generators. Now this plane cuts in perpendicular lines. Therefore, what are the DRs of the normal to the plane? 2 minus 1 C. So 2 minus 1 C becomes one of the generators of the cone. So automatically that satisfies the cone equation. So 2 into 2 into x satisfies the cone equation. So what is the cone equation? Yz plus zx plus xy equal to 0. So what is y? Y equal to minus 1. What is z? C plus zx, c into x2 plus x into that is 2 into minus 1 equal to 0. Obviously this is minus c plus 2c minus 2c plus 2c and then minus 1 equal to 0. So 2c plus c equal to 0, that is minus 2. So obviously c equal to 2. That's it. Okay, next to find the locus of the point from which 3 mutually perpendicular lines can be drawn to intersect the central conic ax square plus by square equal to 1, comma z equal to 0. Let the point P be x1, y1, z1. Any line through the point P becomes x minus x1 by L equal to y minus y1 by m equal to z minus z1 by n equal to k. Now this point lies on the line becomes x1 plus lk, y1 plus nk, z1 plus nk. Now this point lies on the base curve, that is ax square plus by square equal to 1, comma z equal to 0. That implies an implied by a into x1 plus lk square plus b into y1. So b into this becomes b into y1 plus so this is now a into, now this can be, what is k? Since z is equal to 0, this becomes minus z1 by n. So k, replacing k by minus z1 by n, this becomes a into x1 minus L z1 by n whole square plus b into y1 minus m z1 by n whole square equal to 1. That implies a into nx1 minus L z1 whole square plus b into n y1 minus m z1 equal to m square. Now using 1 to the cone, that is we have a into x1 times z minus z1 minus z1 into x minus x1 whole square plus b into y1 times z minus z1 minus z1 times y minus y1 whole square equal to z minus z1 whole square. This contains 3 mutually perpendicular generators implies and implied by coefficient of x square plus coefficient of y square plus coefficient of z square equal to 0. Therefore, we have coefficient of x square, that is a z1 square plus b z1 square plus ax1 square plus by1 square minus 1 equal to 0. Therefore, locus of P is given by a into x square plus z square plus b into y square plus z square equal to 1. That is how. Now, so that's about this particular topic. Okay. Thank you for watching this.